right, so I'm curious, before we go any further, to debrief a little bit with just this. So what are your thoughts as far as why would it be important to know that someone can smell Parkinson's? I mean, it's kind of an interesting party trick if somebody stands up in a meeting and says, hey, I can smell Parkinson's everywhere, but then this university took her seriously. So what are your thoughts? Yes?
Because Parkinson's disease is pretty difficult to detect before it becomes symptomatic, and this would be a way to have early detection before the Parkinson's actually gets to be a problem.
I like it. So possibly detecting before symptoms?
Yeah.
Any other thoughts? Why would we care about smelling Parkinson's? Yeah.
Maybe give someone a reason for screening or testing.
Give someone a reason for screening or testing. I like it. All right, any other thoughts? Yes?
You can like establish, because it's a degenerative disease, you can like allow families to establish like caregivers and caretakers early on.
Allow for early planning for the disease. Yeah, I like it. Give somebody an opportunity to decide what they want to do with whatever time they have for care. Might even lead to like a cause, right? Possible detection of cause. Early treatment. So I hope from this we can see that like there's a reason why they were interested in this potential ability to smell Parkinson's disease. All right, second question. How many correct guesses would you expect Joy to get out of 12 if she really couldn't smell Parkinson's? She was just guessing. Before we answer that question, I want to take it back one step. If she's really just guessing, what's the chance she gets it right for one person? 50%. She's got a 50-50 shot, right? So let's expand that out. If she has a 50-50 shot with one person, she either gets it right or wrong. So if she's guessing with 12 people, how many guesses would you think she would get right if she's got a 50-50 shot? 6. Right. Joy has 50-50 chance of getting it right. So we're going to say 6 correct out of 12. If she's just guessing. So you don't have to memorize any formulas in this class. You will be given a formula sheet to use on the AP exam and on every single test, and we'll even practice during class where to find different things. This is not a formula necessarily. This isn't the type of formula I would give you. This is more just like formulaic thinking. You figure if you have 50% times 12, and that's where we come up with our 6. All right. So did anybody read the box up at the top of the page before you started on this? So it goes ahead and has a spoiler up there. Joy got how many of them right? She got 11 out of 12 right. Does that provide some evidence, at least, that she can possibly smell Parkinson's? Yeah, because we said if she's just guessing, we would expect her to get some of them right. But we would.
Perfect score.
It's almost a perfect score, absolutely. So yes, we have some evidence. 11 is greater than 6. This is number correct. And this is expected correct. All right, so quick show of hands. Who in here thinks Joy really can smell Parkinson's disease? Who in here is not yet convinced? That's fair. It's absolutely fair. Is it possible?
Yeah.
Is it at all possible that she was just guessing and she still got 11 out of 12 right? It is possible. Do you think it's common? So then my next question becomes, how uncommon is it? Because if something's really common and you see it happen, you're like, it's just chance, right? If something really rare happens, it could be chance, or there could be another explanation for it. And if it's really, really, really rare to happen just by chance, the odds are that it's not happening just by chance, the more rare something is. So if I were to ask you, how many correct decisions out of 12, if we were to have Joy do this all over again, how many correct decisions out of 12 would it take to convince you? If she, 10? Yeah? 9?
I think that getting at least 10 correct consistently would be some pretty good proof that she actually can.
So you'd want to see the same phenomenon repeated several times?
Yes.
Absolutely fair. Absolutely fair. Is the 11 that she got pretty convincing? If she got all of them right, would that be convincing? All right, so we're going to go anywhere between 9 and 12 that we would take as convincing. When we talk about this, we're talking about convincing evidence. In statistics, for the most part, when we see different phenomena occur, we make the assumption that it's just chance until shown to be something else. And if it's really, really rare for it to happen just by chance, then we say that that evidence is convincing enough for us to say that this probably did not happen because of chance alone. All right, so I don't know, and I doubt you guys know, how common it would be for someone to just guess 11 times correctly. I think it's a rare event, but I don't know exactly how rare this is. So we're going to do what's called a simulation, and we're going to try to figure out exactly how rare this occurrence is. I did this with my 5th period class, so we're going to be adding to that data so that we have an even larger data set that hopefully means it'll be even more convincing. More data, more convincing. So what I need you guys to do now is to go to this website. Up at the top of the page, let me click a button real quick before you go there. All right. So up at the top, right underneath where it says task number 2, I need you to go to www.stapplet.com/parkinsons.html. You can do this on a Chromebook, you can do this on your phone, you can do this on an iPad. Does everybody have some type of device with them? Okay. I was going to say, I've got an analog version that we can do if you don't have a device with you. Stapplet, stapplet.com/Parkinsons, PARKINSONS.html. Interesting. Okay. It should take you to a page that looks like this. It's mostly white. I'm going to give you guys a code to enter here in just a moment. Yep, you're going to go to where it says enter an existing class code. I want to wait until everybody is at, does anybody need me to put the website address back up? Okay, not a problem. There's the web address. All right. You guys ready for the code? All right. So where it says enter an existing class code, that's the third button down. I know these buttons are super tiny. You are going to enter C, like candy, candy, B as in boy, 1, 6, A as in apple. C, B as in boy, 1, 6, A. And then hit OK. And then right down here, I want you to make your guesses. So just like Joy, we're going to pretend that she is just guessing. Half of these were worn by Parkinson's sufferers and half of these were not. So take your yes and no guesses.
Can you repeat the code, please?
Yes, the code is C as in candy, C as in candy, B as in boy, 1, 6, A as in apple. I'll go ahead and participate too. CCB, Candy Candy Boy, 1, 6, A. After you've gone through and done it, there is a little button down here. You can try your luck again if you think you can do better a second time around. I'm gonna wait just another minute or so. Awesome. We have 56 responses so far. Again, this is putting together with last period's class data. On page 4 in your notes, if you flip the page, $59, $62. I would like you guys to do your best to copy a reasonable sketch of this dot plot into your notes underneath number 5. You don't have to put every single dot because there's 62 dots total. But I do want you to get the overall shape. And for the ones with a fewer number of dots, please go ahead and try to get those as accurate as possible. Right. So I want to talk about the table that's there in number 4 real quick. We're going to talk about this, and I'm going to go ahead and put the graph up as well. If you were still working on getting that copied, I've got that up on the screen now. All right, so this table right here, which I'm sure you probably didn't use, but we're going to talk about this for just a second. I got 7 right on my first try and 5 wrong. So the frequency is the count. How many right, how many wrong. So frequency would be 7 correct and 5 incorrect for me. Frequency gets used in statistics, but not nearly as often as something called relative frequency. Relative frequency, instead of just telling you how many were correct or how many were incorrect, it tells you out of how many. So the relative frequency for correct answers would be 7 out of 12, or 58%. And for my incorrect, 5 out of 12, so 0.42 or 42%. So frequency is a count. Relative frequency you can think of as a proportion or a ratio or a percent. What do each of the dots in that dot plot represent? I'm sorry, one more time. How did we come up with the dots?
Based off of how many each person got right.
Out of?
How many out of 12?
Out of 12, yes. So looking at one whole trial, each one of those dots represents a trial of 12 guesses and how many were correct out of those 12 guesses. So each one of those dots represents a different time that somebody participated in this simulation here. So this is the number of correct guesses from one trial, 12 guesses, in the simulation. We had 62 trials in our simulation. Out of those 62 trials, how many times did somebody get 11 or more correct? 0. 0 out of 62. So if I were to change that into a percent, that's a whopping 0%. That's number 8. So if we're just purely guessing, the number of times that we got the same number correct as Joy was none. Is this evidence more convincing that she wasn't just guessing? Yeah. If Joy was just guessing, her result of 11 out of 12. I'm not going to say impossible, but I would say incredibly rare, right? Would be incredibly rare. It happens pretty much 0% of the time just by guessing, then I wouldn't expect her to just be guessing. I've got one last thing that I want to play for you. I cut the clip off right at the end and didn't play the rest of that video clip for you. I want to play the tail end of it for you now. With the packet. All right. Do listen, though.
She got them all right, apart from one. That person went on to develop Parkinson's. Scientists.
She got all of them right. She got all of them right before the test could detect the other person. One of the ones that said it was not a Parkinson's person went on to develop that disease later. So, at least a little bit. There are a couple things that I want for you guys to do for me tonight, and then a couple things, or one thing specifically over the weekend. The first thing that I want for you guys to do tonight is a very short introduction video. I'm asking for about 10 seconds of your time where you just pronounce your first and last name for me and upload that into Canvas. Please make it a video so that I can put faces and names together, but this way I don't have to ask you like 12 million times what your name is or how to pronounce your name. That's all 100% on me. Yes, please take the book home, and I would recommend leaving the book at home. Pages 2 through 7, please have those pages read for class tomorrow. When we are studying for tests, that's when you would want to make sure to have the book in class, but you do not need to bring the book back and forth to class on the regular. And then sometime over the weekend, if you could get signed up for AP Classroom, that does not open until tomorrow.